Let's look at the solutions of numbers. A natural number n, which is not a perfect cube, has exactly 4 factors. A natural number n, which is not a perfect cube, if it has exactly 4 factors, it is only possible if n is equal to some prime number into some other prime number, in which case the 4 factors that it has would be 1, the first prime number, the second prime number, sorry, the first prime number is a factor, the second prime number is a factor, and finally n itself as a factor. These 4 would be the factors. So we've been told the sum of the positive factors of n that are less than n is 2014. So sum of these 3 numbers is 2014, which would mean sum of the 2 prime numbers involved plus 1 is equal to 2014. So if I get rid of this one, this 2014 will turn to 2013. And now 2 prime numbers are adding up to 2013. The only way this works is if one of them is even and one of them is odd. Among the prime numbers, the only even prime number is 2. So the other one will be 2011. So the actual number that we're dealing with, n, will be equal to 2 into 2011, which is equal to 4022. Answer to the question should be 4022. Next question. A and B play a game using 2 dice, namely X and Y. X has 1, 2, 3, 4, 5, 7 printed on its 6 faces, whereas Y has 2, 3, 4, 5, 6, and 8 printed on its 6 faces. There is only one number printed on every face of the 2 dice. In turns, each of A and B rolls both the dice simultaneously and records the product of the 2 numbers appearing on top of the 2 dice as their respective scores. If the sum of the scores of players A and B is an even number in a round, then how many distinct scores A could have had in that round? The good thing you can notice here is this information is pretty useless, because effectively what this says is if A has odd score, then B should also have odd score, and if A has even score, B should also have an even score. Effectively, A can get an odd score, A can get an even score, so nothing really changes. So let's go ahead, record all possible scores that A can get. 1, 2, 3, 4, 5, 7, and here we have 2, 3, 4, 5, 6, and 8. This much we have got. Now, what I will do is I will simply go ahead and write down all the products and see wherever I'm getting numbers which are getting repeated, those numbers will be eliminated. I get 2, 3, 4, 5, 6, 8. Here I get 4, 6, 8, 10, 12, 16, 6, 9, 12, 15, 18, 24, 8, 12, 16, 20, 24, 32, 10, 15, 20, 25, 30, 40, 14, 21, 28, 35, 35, 42, and 56. From these, let me cancel out all the repeat values. The first column will have everything unique. 4 is getting repeated, so goes. 6 is getting repeated, so goes. 8 is getting repeated, so goes. Okay, then 10, 12, 16 are new, unique values. 6 is getting repeated. 1 into 6 is same as 3 into 2, so gone. 3 into 3, I'm not getting. 12 is 2 into 6 and 3 into 4, so gone. Okay, nothing else. 8 is 1 into 8, so gone. 12 is already available, gone. 16 is already available, so gone. 24 is 3 into 8 or 4 into 6, so gone. 10 is already available, 2 into 5, 5 into 2, same values. 15 is 3 into 5, 5 into 3, already available. 20 is 4 into 5, 5 into 4, already available. 25 is not available anywhere. 30 is not available anywhere. 40 is not available anywhere. Everything in the last column would be different because these are the only numbers that are multiples of 7. So let's count how many unique values we have. In the first column, I have 6 different unique values. In the second column, I have 3 different unique values. In the third column, I have 4 different unique values. In the next column, I have 2 different unique values. In the next column, I have 3 different unique values. In the last column, I have 6 different unique values. So 3 plus 3 plus 4 plus 2 is 12, 12 plus 12. The distinct scores that A could have had is 24. Next, consider set G of all integers between 100 and 9998, including the extremes. Call two integers A and B in G to be in the same category if digits appearing in A and B are the same. For example, if A is equal to 101, B is equal to 100, then C is equal to 1000 and D is equal to 120, then A, B, C are in the same category, but C and D are not. Okay. A, B, C are in same category because the digits used to make A, B, and C are the same two digits, 0 and 1, 0 and 1 always. But for D, because a new digit 2 is coming into consideration, it is not in the same category. Okay. Find the number of different categories that can be formed out of G. This question is basically saying, how many distinct digits do you have? If you have all the digits is identical, you will have 9 categories created. If all your digits are composed only out of 2 distinct digits, if all the digits that you're making is composed out of only 2 distinct digits, it will be 10C2. If all your entire number is made out of only 3 distinct digits, that will have a category 10C3. And if your entire number is composed out of 4 distinct digits, then it will be 10C4. These many categories will be created. So you get 9 from here, 45 from here, 120 from here, and 210 from here. So we get 54 and 330. So altogether we get 384, or option A as the answer. S is equal to 7 plus 77 plus 777, so on and so forth, up until how many 7s do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. I can write S as, if I take out 7 common, I have 1 plus 1, 1 plus 1, 1, 1 plus 1, 1, 1, 1, blah, 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 plus 9 times 1, 5, 6, 7, 8, 9. Or I can go ahead and write it as, see the unit digit, 1 is coming 9 times, so the unit digit will be 9. Then at the tens place, 1 is coming 8 times, so I will get 8, then I will get 7, then I will get 6, then I will get 5, then I will get 4, then I will get 3, then I will get 2, I will get 1. This is effectively the number. This is the number that we are dealing with. So S is this. I can happily multiply and get to the precise value of S now. 7 into 9 is 3, 6 carried over. So 6, I get 2. Let's see. Minus 11 into 7. Okay. 6 carried over again. 7 into 7 is 49. 6 carried over. So 5 carried over. 6 into 7 is 42. So 7, 4 carried over. 5 into 7 is 35 plus 4 carried over. So 9. 3 carried over. 4 into 7 is 28 plus 3 carry over. So 1. 3 carried over. 3 into 7 is 21 plus 3 carried over. So 4. Okay. 2 carried over. 2 into 7 is 14 plus 2 carried over, so 6. 1 carried over. 7 into 1 is 7, so 8. This is the number that is getting created. Let us now see what is the sum of the digits. I will make groups of 10 and cancel. I have 10. I have 10. I have 10. And I have 15. So if I add these numbers up, the sum of the digits turns out to be 45. Okay, last question. If x cube into y square is equal to 2 raised to the power 6 into 3 cube into 5 cube into 7 raised to the power 10, find the minimum value of 4x plus 5y. Now this is a question of presence of mind, simple presence of mind. Can you see what I have here is y square. What I have here is y square. Although the result on the right hand side is positive, there is no instruction that x and y have to be positive. There is no instruction that x and y have to be positive. So can I go ahead and say, let x be equal to 3 into 5 and let y be equal to 2 cube into 7 raised to the power 5. Negative version of this. Can you see if you multiply x, if you cube x, if you multiply x with itself 3 times, from here you will get x cube is equal to 3 cube into 5 cube, and from here y square will indeed turn out to be 2 raised to the power 6 into 7 raised to the power 10. So x cube into y square will indeed give you all the terms as required. So the minimum value of 4x plus 5y, 4x plus 5y, this number will be positive. 4 into x will give me 60, but 5y will be a negative number and a massively negative number. This is 8. This is 16807. This will be a 5 into 8 into 16807. Can you see the net result will necessarily be negative? So of course, the first 3 options are incorrect. The answer to the question has to be option D, none of these. This question hinges on you being able to see if you're doing y square, y could very well be a negative number. So how bad a negative number can you get for y? That you have to think of. As soon as you got that, your question would be done. That will be all for this episode. Hopefully you learned something. Okay, bye.